Good morning, Class 3 and Class 4. Welcome to your Monday morning reading session. Your last week before you break up for your 6 weeks holiday. Hopefully you're all feeling really excited, but also looking forward to finishing our book that we started last week. Titus Rules OK. So today I'd like you to read chapters 7 and 8, please, and then I've got some questions for you to answer. Okay, so your questions today. What did Sir Gregory see when he got to the royal bedroom? What does DCM stand for? Why did Chum not like Titus? What made Titus eventually start a fight with Chum? And how do you think the Queen felt when she found the corgis fighting, and why? So pause me now while you have a go at answering those, and unpause me when you're ready for the answers. Okay, so the answers are there for you. So Sir Gregory saw half a dozen guardsmen, jewellery scattered over the floor, and Sidney hopping about with Titus attached to his ankle. DCM stands for Distinguished Corgi Medal. And Chum didn't like Titus because he was jealous that he had been allowed into the drawing room earlier than any other puppy, and he didn't like the fact that he was the Queen's favourite. Titus eventually fought with Chum because he called his mum a silly old fool, and anything along the lines of the Queen feeling angry, upset, shocked, horrified, and because it was absolute chaos and her dogs don't usually fight, and she was also worried about Titus in case he was hurt. Okay, year 4, onto your maths for today. So today we're going to explore adding 2 or more fractions. It's the same as it's been the last few weeks. You will have the video of the man teaching you and then your questions at the end.
Hello and welcome to our second week of lessons about fractions. Today we're going to look at adding fractions, one of the 4 main operations, of course, that we can do with numbers. When we get onto the operations involving fractions, people can too often get really quite confused about what's going on. One thing that really helps me not to get muddled when I'm adding or subtracting fractions is to remember that fractions are types of numbers, and they behave just like whole numbers do. And I think that may really help us. So I want you to keep that in mind as we're working through the tasks and the questions of the lessons today and tomorrow. So here we have got a question. 3/5 add 1/5. So let's have a read. That's easy. 3 add 1 is 4 and 5 add 5 is 10. So the answer is 4/10, which would seem logical. However, let's have a think using a picture or a bar model as exactly what's going on here. There we've got our 3/5, and I think by now we're really comfortable drawing fractions using bar models. 3/5, and we're adding to 3/5 1/5. So let's do that. Adding involves putting things together. Let's put 1/5 with 3/5. What do we have? We do have 4, but we've got 4/5, haven't we? Because below we've got 4/10, and we can see in fact 4/10 is smaller than 3/5. It's smaller than the number we started with, and when we're adding positive numbers, we will end up with a larger number as our answer. So the answer is 4/5, not 4/10. But why don't we add the denominators? Because it does seem like a sensible thing to do. So why is the answer 4/5, not 4/10? Because when we're adding fractions or subtracting fractions, the denominator is like the label or the unit that we're dealing with. So we could be dealing with pounds, we could be dealing with centimetres, sometimes units might be children. If we say we've got 31 children in the class and 4 are absent, children is the unit. So if we have a unit of apples and we have 3 apples, add 1 apple, I think we all know that the unit stays the same. We're not going to have 4 bananas. 3 apples, add 1 apple, well that's going to be 4 apples, because apples is the unit. So in the question we just saw, fifths is the unit, fifths is the label. It tells us what we're dealing with. So have a go at this question. Eva eats 3/12 of the donuts and Mia eats 4/12 of the donuts. What fraction do they eat all together? Let's have a look at this question in more detail. So we've got our box of donuts, and there are 12 donuts in the box. We've got an array there, haven't we? Donuts often come in boxes which look like arrays. So we've got one whole box is 12 donuts, 12 twelfths. So one donut is 1/12. So if Eva eats 3 of the donuts, so 3 twelfths, and Amir eats 4 of the donuts, 4 twelfths, altogether they've eaten 7 twelfths. They've eaten 7 donuts. Not 7 24ths, because as you can see, we don't have 24 of anything. We've got 12 of something. We've got 12 donuts. Let's have a look at this one together. 2 eighths add 3 eighths. And a bar model really helps us, like we saw in the first question. There's 2 eighths. I'm going to add 3 eighths, showing a different colour. How many eighths have we got? 5 eighths. Remember, the denominator stays the same because that's the label. That's the unit. That's what we're adding. And we can show that in a part-whole model. There's 5/16. And when we show it visually, we can really see how 5/16 wouldn't make any sense because we're adding 3 eighths to 2 eighths. So we're going to get an answer that's going to be bigger than both 2 eighths and 3 eighths when we add those two together. And we can see there's 5/16 is a little bit bigger than 2 eighths, but it's smaller than 3 eighths. Let's have a look at one more question together. We're again dealing with fifths, and we're starting with 3/5. Okay, and we're adding 4/5. I wonder if you can see a slight problem with our bar model at the moment. We can add 2/5 with no problem, but we've got another 2/5 to add, haven't we, because we're adding 4/5 in total. So what do you think we could do? One thing you may be tempted to do is just do that, because we've now added 4/5, but do we have fifths anymore? No, we don't, do we? We've in fact created sevenths there. So no. What we need to do is we need to draw another bar of fifths. Okay, a second bar, because we can only have 5/5 in one bar. So we've got 2/5 in that top bar, but we've got another 2/5 to add. So there we go. We can see now if we add up our total, we've got 7/5. That's quite a special type of fraction. It's called an improper fraction. Sometimes it's called a top-heavy fraction. An improper fraction is a fraction where the numerator is larger than the denominator. We can see there 7 is larger than 5. So 7/5, we could write that as a mixed number. Think back to our equivalent fractions. And we can see using the bar model really easily to see 1 whole, and 2/5. But either way of writing is the correct answer. It's the same number. 7/5 is just the same as 1 and 2/5. It's the same number shown in two slightly different ways. So now it's over to you. I've given you a bar model for the first question, but please use a bar model for all 4 questions. It will really help you understand what happens when we add fractions. So the first one, we've got 3/7, and we're adding 2/7 to 3/7, so we're going to end up with 5/7. Remember, sevenths is the unit, is the label, it tells us what we're dealing with. Okay. Second one, well, we're starting with 3/8, and we're ending up with 7/8. So what have we got to add to 3/8 to get 7/8? Well, what do we have to add to 3 to get 7? We've got to add 4, haven't we? So if we're dealing with 8, we've got to add 4/8, which of course we could write, if we wanted to, as an equivalent fraction, as 1/2. Let's have a look at number 3. So we've got 3/5 that we're starting with. We're adding 1/5, and then we're adding another 4/5. So that's like we looked at together, where we've got to draw another bar to show fifths. So we can see there, we've got 3/5, add 1/5, and 4/5. We can see we've got 8/5 in total, and we can also see using the bar models that is 1 and 3/5. And the last one, we've got, again, this one, it's like a missing digit type of question because we've got the answer, as it were, given. Let's have a look. 1/6, add 3/6, so that's so far so good. And we're aiming for, what we need to get to is 1 and 1/6, so let's show that. There we are, 1 whole and 1/6. So what have we had to add to get up to that 1 and 1/6? Well, we've added another 3/6, haven't we? Another 3/6 there. Using the bar models really helps us, and it really helps us avoid that misconception, that mistake that people often make, where we're adding the denominator. So for number 1, we'd end up with 5/14. Using the bar model makes it almost impossible to make that mistake. Let's have a look at this type of question. Again, it's like the missing digit question. Some number of 9s add 2 9s is equal to 1. what's really important here is we understand what 1 is in ninths. So there is our bar model in ninths. One whole would be 9 ninths, wouldn't it? 9 ninths, when we've got the numerator and the denominator the same size as each other, that's equal to 1. 10 tenths is equal to 1. 2 halves is equal to 1. A million millions is equal to 1. So 9 ninths is equal to 1. So if we replace in our question 1 with 9 ninths, it becomes quite straightforward because we can see something add 2 is equal to 9. So there's our 2. Well, what do we have to add to 2 to get 9? 7. 7 ninths add 2 ninths is equal to 9 ninths, and 9 ninths is equal to 1. 2 questions like we've just had a look at, making equaling 1. Draw your bar models to help you. So number 1, we've got 4. We'd have to add 4 elevenths to 7 elevenths because 4 add 7 is 11. So 4 elevenths add 7 elevenths is 11 elevenths, which is equal to 1. And the second one, so we've got 1 eighth, and we'd have to add 7 eighths to equal 1. I'm going to go through this question in quite a lot of detail, but do have a go first, and then we'll explore the answer. So hopefully you could use what we've talked about with 1 to help us here, because we need to equal 2. Well, hopefully we're confident that 5 fifths is equal to 1. So how many fifths do you think equals 2? 10 fifths. 10 fifths is equal to 2 or 2 wholes. So now, really, the question is a number bond question. It's a number bond we've known since key stage 1. 4 add something is equal to 10. 4 fifths add some number of fifths is equal to 10 fifths. It's going to be 6, isn't it? 4 fifths add 6 fifths is equal to 10 fifths, and 10 fifths equals 2. So using that understanding that 9 ninths is equal to 1, so 18 ninths is equal to 2, have a go at questions 4 and 5. Do draw the bar models to help you. Question 5, we've got to have quarters that equal 3. So if 4 quarters is equal to 1, 8 quarters is equal to 2, I wonder how many quarters will equal 3. Drawings will really help you with both those questions. Okay, so number 4, well, we need to get 18 ninths. 10 ninths add 8 ninths will be 18 ninths, and 18 ninths is equal to 2. You can see that with our bar model. We've got 10 ninths, so that's 1 and 1 ninth. We need 8 more ninths to get up to 18 ninths in total, 2 in total. Number 5, there were lots of parts to add here. So this is what our bar model would look like. 1 quarter, add, then we've got 7 quarters, which in fact go over 3 different bars. We've got 4 of them in the one on the right, and then 1 in the first bar, then 2 in the bottom bar, so that's 7. Add our 2 quarters, and we're aiming for 3, so we needed 12 quarters. 12 quarters is equal to 3 wholes. So we needed to add, we can see it in the light blue, another 2 quarters there. Because 1, add 2, add 7, add 2 is 12. So 1 quarter, add 2 quarters, add 7 quarters, add 2 quarters is 12 quarters. And 12 quarters is equal to 3. You're now ready to have a go at using.
Okay, your questions are on the screen now for you. Pause me while you have a go, and then unpause me when you are ready to see the answers. Okay, the answers are there on the screen for you. Any problems, please feel free to email me.
Good morning, Class 3 and Class 4. For writing today, we're going to be using the Titus Rules OK book that you guys have been reading. Okay, so we're on Monday, the 13th of July. Okay, so in Chapter 7, which you've read today, Sydney was arrested for stealing the Queen's jewels. However, he has escaped. So, I want you to think about what the public need to know to help the police find Sydney, the footman thief. The public need to know what Sydney looks like, where he was last seen, what crimes he has done. So what's the crime that he's committed? So think about why are the police after him, and what the public should do if they see them. So have a think about who they might need to call or contact, and perhaps it might be important for the public to know to maybe stay away from him if he's not a pleasant person. So your task today is to create a wanted poster for Sydney the Footman Thief. Now, in the book, there is lots of description for Sydney. So I want you to use the book to help you to describe him. Now, you can include a picture in that. That's absolutely fine. But I want some really brilliant descriptions to make it nice and clear so anyone could spot Sydney, even if they've never met him before. So good luck with that today, guys. I look forward to seeing what they're like. Bye.